Hey everyone, welcome to homework 1.4. So today we looked at equations with two variables, right? We started with looking at equations in one variable. Most of what you're doing in your homework today is looking at equations in two variables. So we start with Kieran's family. She's having a football game. They want to serve sparkling water and pretzels. That's an interesting spread for a football game. They're preparing 12 ounces of sparkling water and 3 ounces of pretzels per person. All right, so that's how much each person is allowed to eat at this party. Including Kieran's family, there will be 10 people at the gathering. So we have a lot of information already. We have 12 ounces per person and 10 people. So we can very quickly say see, look, I already calculated. That's going to give us 12 times 10, which will give us 120 ounces that we need of sparkling water. And then we also have 3 ounces of pretzels times 10 people, and so that's going to give us 30 ounces of pretzels that we need. So it says a bottle of sparkling water contains 22 ounces and costs $1.50. All right, so we know that we need 120 ounces, and each bottle contains 22 ounces. So to figure out how many bottles we need, we're going to do 120 divided by 22. Now, you can go ahead and long division that, or if you have a calculator at home, you're welcome to use it. But you're going to do 120 divided by 22. That's how many ounces total we need divided by how many ounces we are in each bottle. And that's going to give us 5.45 repeated, okay? So that means we're going to need more than 5 bottles, otherwise we'll be a little bit short. So we need 6 bottles. All right. And then it says a package of pretzel contains 16 ounces. Well, we need 30 ounces. So 30 divided by 16 is going to be 1 point something, which means we're going to need at least 2 packages of pretzels. So we already know how much we need and how much it costs. Now, they're then giving us all this information. Let N represent number of people, S represent the ounces of sparkling water, P represent the ounces of pretzels, and B represent Kieran's budget in dollars. Which equation best represents Kieran's budget? But we don't actually need all of that information because we know how many packages Kieran needs and how much that costs. She needs 6 bottles, which is $1.50 each, so 6 times $1.50, and then she needs 2 packages that are each $2.99. So by looking at these, we can see that D is our best one because it has that budget already configured. 6 bottles of water, 2 packages of pretzels, times the amounts that each of them cost is going to give us her budget, how much it's going to cost her. Now to look at A, we see we have 12, that's the number of ounces, times S. S would be the ounces of sparkling water. So 12 times the ounces of sparkling water is not going to give us budget. There's no money factored in there. So we know that that's not true. Same thing with B. There's no money factored in here. We have 12 times the number of people, 3 times the number of people. That's going to give us how many ounces we need, but not our budget. And then letter C finally has some money, but that's 150 times S times the ounces of sparkling water. And we're not paying 150 an ounce. That would be very expensive for water. So 150 an ounce doesn't make sense. So we can eliminate C, leaving with our best option, D. All right, number 2. The speed of an object can be found by taking the distance it travels, so distance, D, and dividing it by time, T. That gives us speed. An object travels 100 feet, so that's the distance, in 2.5 seconds. That's the speed. Equals S. All right, it's being measured in feet per second, so we see seconds and feet per second, so we don't need to do any conversions to minutes or anything like that here. So if we do 100 divided by 2.5, and you should recognize 100 divided by 25 as 4. So 100 divided by 2.5 is going to be 40. So S equals 40. Remember, we're measuring in feet per second. Number 3 says a donut shop made 12 dozen donuts. Okay, for this you need to know that a dozen is 12. So 12 dozen donuts. So 12 times 12 will give us the total number of donuts, 144 donuts. It says, which expression represents how many donuts each student would get if the donuts were equally distributed? So if we're dividing up these, we're doing 12 times 12 and then dividing by X. All right? Now that's the equation I get. We have to look at our answer options here. A is obviously not going to work. Okay, B, ooh, we have a chance here. If we were to multiply 12 over 1 times 12 over x, we would get 144 over x. So that is equivalent to this equation that I wrote over here. 12 times 12 times x would give us 144x. We're not multiplying the donuts times the number of people, we're dividing by people, so that's not going to work. And then same thing, D just gives us the total number of donuts, it doesn't tell us how we're distributing them. All right, number 4, the crew for the spaceship Zeta. Look at all this red underlining because it's fake names. The Romulans and the Webbins. Okay, so the Romulans have 2 hands and the Webbins have 8 hands. They're aliens, okay? The crew has a total of exactly 84 hands. Then how many aliens of each species could be chosen, assuming there is at least one of each type? Select all that could be true. So let's make an equation for this. We have 2 hands per Romulan, so that's 2R, plus however many Webbins are on there, and they have 8 hands each, so 8W. And then we say total, we have 84 hands. All right, so this is measuring hands of Romulans and hands of Webbins based on how many Romulans and Webbins there are on this spaceship. All right, so what we can do now is take each of these answer options and plug them in and see which works. So I'm going to model for the first one, B, C, and D you can do. I'm going to say, it says select all that can be true, so you know there's going to be more than one correct answer. So we could say 2 times 2, if there's 2 Romulans, plus 8 times 10 equals 4 plus 80, which equals 84. So this one is true. A does in fact work. That is a potential solution. We could have 2 Romulans and 10 Webbins and still have a total of 84 hands on the crew. So your job now is to check each one of these to see which one of those works. Okay, and it might be more than one. Just a hint there. All right, try each of them. All right. Number 5, a concert at the Capital One Center sells 2 levels of tickets. General admission is $30 and VIP is $60. Name at least 2 combination of tickets that could result in a revenue. That's how much Capital One Center would bring in, $6,300. So let's go ahead and say general admission tickets are represented by G. VIP tickets can be represented by V. So we have 30 times the number of general admission tickets that we sell, plus 60 times the number of VIP tickets we sell, equals, we want a revenue of $6,300. Sorry about that little, oh, making it worse. Okay, all right, so we can say that if we are doing this combination, right, you're going to go ahead and substitute something for G and see what you would get for V. They do need to be whole numbers, right, because we would sell 1 whole ticket. So let's say we do 10 general admission tickets. So if we do 10 general admission tickets, we would do 30 times 10 plus 60V equals 6,300. This is going to give us 300 plus 60V equals 6,300. Okay, I'm going to subtract my 300 on both sides. Okay, minus 300. This is going to leave me with 60V equals 6,000. Now I can divide both sides by 60. And if you know this trick, right, we can look at the number of zeros, cross out the number of zeros. 600 divided by 6 is going to give us 100 there. All right, so one possible solution is if we sell 10 general admission tickets and 100 VIP tickets, that would bring in that amount of revenue. So I did one for you. I want you to come up with one more solution, right? Come up with one other solution. Try something for G or V and see what you get for the other one. And that, as long as it works and it works out evenly, that gives you a solution. So this is the one you should have from Miss Lee. And then I want you to come up with one other solution that could work there. All right. This part below is a review, but for some of you, if you skipped 8th grade math, you might not have seen this before, so I'm going to go over this as some practice. It says solve for the variable given. So literal equations means we are looking to solve for a variable, and there's often more than one variable in the equation. When this happens, we treat that variable just like we would any number. So here we have G equals 6x, and we want to solve for x. Well, if I want to solve for x here, let me use my pen here. If I want to solve for x here, I would divide by 6 on both sides, right? And then this will cancel out because 6 divided by 6 is 1. And we get x equals g divided by 6. That's it. That's your answer, okay? That's what x equals. If we knew what g was, we could plug it in and we could find out what x equals very easily this way. Let me show you another example with 2. 2 says, again, we're solving for x. Well, first I want to get rid of this 2 on each side, so I'm going to add 2 to both sides. Negative 2 plus 2 is 0, so that cancels out. Now I have u plus 2 equals 2x. Well, I still need to solve for the x, so I'm going to divide both sides by 2, and we get x equals u plus 2 all over 2. That's it. That's your answer. X equals u plus 2 divided by 2. All right, literal equations aren't going to look pretty, which is why students are sometimes resistant to them, but you're doing the exact same thing that you know how to do with any equation. Let's try number 3. Now, number 3 gets a little tricky because we have a negative in front of the x, so there's a couple ways that you could approach this. I generally like to make my x positive because it just works for my brain, but you can do it any way that you like. So let's go ahead and say, let's get rid of the m. Let's subtract the m on this side. The m is positive, so in order to get rid of it, we're going to subtract m on both sides. All right, this m minus m will cancel out, and then we have z minus m equals negative x. Well, we can't have a negative x because we're solving for just x. So to make it positive, we can divide both sides by negative 1. And now that becomes a positive. So now we have x equals z minus m over negative 1. Well, if we want to go ahead, we can divide that through, and we'll end up with negative z. A negative m divided by a negative 1 becomes a positive m. You can also write this as x equals m minus z. So that's one way to do it. Now, I'm showing you this way because it's important that you recognize if you need to make a number positive, you can either multiply or divide by a negative number, and that will take a negative and make it positive. But if there's, oops, that's not the eraser. The other way that I could have done this is, and I know a lot of you, I've seen you do this in your brain already, is I can move the x to both the other side, and we can make x positive, right? And so this then becomes 0, and we have x plus z equals m. Now I can subtract z from both sides, and I get x equals m minus z. Again, you get the same answer this way, so it's totally fine to do it this way. I just wanted you to see that if you end up with a negative x, the way to neutralize that is to multiply or divide by a negative 1. All right, number 4, we have g equals ca, solving for a. So this is multiplication here. We're going to divide by c then, and we will, c divided by c is just 1, so we get a equals g divided by c. That's it. 5, we're solving for x. All right, this one's a little bit nicer because x is positive, so I'm going to do plus k on both sides. Add it to get rid of this. Negative k plus k is going to be 0, so we get u plus k equals x. All done there. All right, I want you to try 6 on your own. Now that I've shown you multiple examples like that, you can 100% do this. You're solving for x. How do you get rid of that c? All right. 7 I'm going to do, and I'm going to have you do 8 on your own because you can do that. 7 I'm going to do just because it's a little tricky with the a in the denominator. So for this one, I want to solve for a. So I really want to get that a out of the denominator. So I'm going to multiply both sides by a. A divided by a then becomes 1, so that cancels out. And we're left with a times u equals k. Now again, I'm solving for a, so I need to continue along and do au equals k. Let's divide both sides now by u, and we get a equals k over u. Okay? That's one way to do that. I'm going to show you one other way that you can think about this one too, since we have a fraction, all right, and a denominator. So another way you can think about this is cross multiplication. U over 1 equals k over a. You can cross multiply these, and you will get au equals k. Again, I still need to get a by itself, going to divide by u. And so you're going to end up with the same answer where a equals k over u. We're getting, again, that same answer. It just looks, we just did it a little bit differently. So that cross multiplication, this some people call butterfly method, is one way to think about it. If you haven't been taught that, it's a little bit of a faster way to sometimes manipulate that problem. All right, again, you do 6 and 8 on your own. You're capable of doing those. If you have any questions, you know how to reach me. My phone number is also on the homework, so you're welcome to text or call. Happy homeworking. And, oh, your code word. Your code word will be brown, because you may have seen that Mr. Allen just sent me a text message about Miss Brown during this homework video. So, Miss Brown. Brown is your code word for today. If you put that at the top of your paper, get extra credit. See you tomorrow.